Welcome to the classroom. In our last lesson, we were talking about cameras. And one of the things that we explained was that cameras can be divided into two categories. You have film cameras, which are called film cameras because the medium that they use to record images is something that we call film. The other type of camera is what we call a digital camera that uses a sensor to capture the image and then takes that image and sends it electronically or digitally to any type of digital storing device. In this case, a memory card works fantastically with cameras because of their size and portability. So we gave you a list of different types of cameras. Some of you identified some of them. All of you are aware of the cell phone camera, right? But we spoke about all kinds of cameras, beginning with the film cameras and ending with the 360-degree camera. In the last lesson, I told you that today we will be exploring what we call CINE cameras. The difference between a CINE camera and a regular camera is that a regular camera is designed for still photography. In other words, it's designed for the taking of pictures that do not move, images that are static. In the case of a cine camera, these do not take photographs. These are specially designed for recording moving images. Cameras emerged as a technological breakthrough in the early 1800s thanks to advances in the field of optics. And I remember telling you that optics was a branch of physics that dealt exclusively with what? Does anybody remember? No? Okay. It's a study of light. Let me blow your mind away today. I'm going to ask you a very simple question. Can you see me? Only two people can see me. What about the rest of you? Can you see me? Are you sure? Would you bet your life on that? I'm sorry to tell you that from an optics point of view, if you were waging your life, you would have lost it. You are not seeing me. As a matter of fact, if you were in front of me, I wouldn't really be seeing you. What you are seeing is the light that is bouncing off of me. You are seeing light. Of everything that can be seen in the universe, the different frequencies, from X-ray all the way to radio waves, you only see a narrow band in that spectrum. That narrow band that you see is called the visible light spectrum. And your eyes are designed to see only in that frequency, which is a very narrow one. So if I'm saying that, what's the implication here? That you cannot see in the other frequencies. Your eyes are not capable of seeing in other frequencies. Your eyes cannot see in gamma. Your eyes cannot see in the X-ray frequency. Your eyes cannot see in the infrared frequency. Your eyes cannot see in the radio frequency. Your eyes cannot see in the ultraviolet frequency. You see in the visible light frequency. You should realize that you are almost blind. Of all the things that can be seen in the universe, you can see very little. Did that cook your noodle? So your eyes are a tool that see visible light, what we call visible light. The other lights are invisible. And the camera is a tool that allows us to record in that frequency. So what enters a camera, what a camera records is light. Again, when we talk about cine cameras, they come in two categories. We have film cameras and we have digital cameras. And again, which one is better and which one is not, it depends on what you're looking for. Because again, I will restate that one offers advantages over the other. And the celluloid camera has been around for over 120 years. It's been around for a very long time. One of the things about the film camera is that using film cameras can be time consuming. One of the drawbacks of using a film camera is that you cannot get an immediate feedback of what you recorded. You will have to record the image, send it to a laboratory, as I told you in the last lesson, have someone develop that film, and then see what you did. And that could take a while. Back in the older days, it took longer than it takes today, but today, the situation is still the same. You do not get immediate feedback of what you did. And another thing that you probably don't know is that celluloid does not record sound. It does record images, but it does not record sound. Sound is entirely a different thing. Sound and light are two different things. Sound is a mechanical wave. Light is a frequency, or it can also be seen as particles. So they are two different things. However, you're probably wondering, why do people still use film today? The reason is because film offers a series of aesthetic advantages over digital cameras. When we use the word aesthetics, we're talking about the beauty of something. Film, still to this day, looks better. The images that are recorded in film look better than those that are recorded digitally. They have better resolutions, they have more vivid colors, and they represent the reality that was recorded in a more faithful way. That is why some filmmakers still prefer to use film in spite of the disadvantages it might have in our to-go world where everything has to be instantaneous. So what I want to impress upon you is that while film videography, not videography, film recording can be very beautiful and give you fantastic results, the workflow is slower. Some people prefer to work faster. So those people are going to gravitate away from film. Another advantage of film is that it comes in different gauges or sizes that you can use. Although there is a universal gauge or size that is used in the film world today. Any questions so far? Okay, back in 1932, they invented something called the 8mm camera. In the mid 1960s, they came up with Super 8mm, which was slightly larger. And this one became like the most popular type of camera that families would use because they were smaller, they were more portable, they were much more affordable. And if you went on a vacation, well, dad could take his Super 8 camera with him, buy some some rolls of film, and record the family vacation. So we have Super 8 and 8mm. We have 16mm, which is double the size. This kind of camera was created in 1923. It was used professionally, but not for long because the quality was not that good. There was another gauge that had a better resolution. In the early days of TV in the 1950s, however, 16mm saw like a resurgence and it was widely used for a while. For a while. 35mm is the international standard gauge, and it's been that way since 1909. Every film that is made for release in the world is this size, still to this day. This is the preferred size for motion picture uh, photography. However, since 2008, we've been seeing a shift towards digital because digital is taking over the bulk of the market of film recording. And there have been many changes in theaters where they're using digital formats now. But still, to this day, in the film world, those that use film, this is uh, this is the size to go. There's an even larger size, which is 70 millimeter. Almost no one uses this because the cameras are so big and heavy. Very few uh, filmmakers use this. The last one I remember was Quentin Tarantino when he shot The Hateful Eight that came out like 2 or 3 years ago. And it's also known as Panavision. And the image is gorgeous. It's beautiful, especially if you're shooting a landscape or a panorama. It is fantastic. This is the granddaddy of another format that you're probably familiar with. Have you ever been to an IMAX theater? Anyone? Have you seen a movie in IMAX? Well, I've in Puerto Rico, I think there's an IMAX theater in Rio Piedras. I've never been to that one. The only time I've been to any IMAX theaters is when I've been visiting the United States. A few years ago, when I went on vacation to Orlando, we went to a theater in Universal Studios. That's when the first Avatar movie came out. And although Avatar is not one of my favorite films, I do love science fiction, but the movie was like, okay, all right, it's not a bad movie. It's a good movie, but it's not great for me. But seeing that movie in IMAX is one of the greatest cinematic experiences I have ever had. Seeing that movie in an IMAX screen was fantastic. The level of immersion, the quality and beauty of the images was astounding. It was gorgeous. It was a fantastic experience that I haven't forgotten, and I hope I never forget. I went to a IMAX theater recently as last year. We were in visiting a relative in Missouri, and we went to see Terminator: Dark Fate, and it looked pretty good. It was not as fantastic looking as Avatar was, but seeing a movie in IMAX, that resolution is fantastic. It just doesn't get better as quality wise, image wise. The movie is something else, right? As far as the movie, how good the movie is or how bad it is, that's entirely a different story. But I'm talking about how it looks, and it looks fantastic. So if you've never seen a movie in IMAX, I would recommend that you experience it. It's a little bit more expensive than a regular movie, but you cannot beat the image. So IMAX is the son of 70 millimeter, and recording in IMAX is a very complicated affair because I told you these cameras are huge. They are very, very, very big. And I don't know of any movie that has been recorded completely with an IMAX camera. What some directors do is, since this is so hard to use, they record some parts of a movie with an IMAX camera and the rest is recorded with a 70 millimeter. Okay. Um, then we have video. Video has been taking the world by storm. Why is video used? There are many conveniences to using video. One is that the workflow with video is faster. When you record something with video, you get immediate feedback. The other reason is shareability. Sharing film is complex, it's complicated. Sharing video images is very simple. The world that we live in right now is very digital friendly. We can quickly not only see what we did, but share it instantaneously with someone at the other side of the world. Let's say you're collaborating with someone in France. You can record something now and send it right now to someone in France, and that person will be seeing it right now. And that's a heck of a thing. Video, the image might not be as good as film, but it's getting there. It's getting there. And the person that pioneered the use of video in filmmaking was George Lucas. You probably heard of this guy. George Lucas is the creator of Star Wars. And back in 1999, when he was shooting the prequels, the first movie was called The Phantom Menace, Star Wars The Phantom Menace, Episode 1. That movie was partially shot in video, and then the next movie, which came out in 2002, I think, The Clone Wars, was shot entirely in video. So from then on, many directors have decided to switch because they prefer the workflow that digital gives them. So do I. I think that filmmaking is too complicated for me to complicate it more than it already is. So I work with digital, which is also cheaper than film. Film is also more expensive. But those that are more purists prefer film. More power to them, right? More power to them. Okay, it talks about how movies are shot in different resolutions. You see that it talks about a movie called The Hobbit that was shot in a different resolution that is normally shot. Resolution is a concept that we're going to discuss here. Resolution has to do with the amount of detail that an image holds. Right now, you're seeing my image in this frame here at a very low resolution. It's low quality. I can improve the quality, but it will make the computer record more information and it will work harder because resolution has to do with the amount of information. And images that are digital are made up of information, digital information. And that information is in the form of something called a pixel. Does anybody know what a pixel is? Exactly. Right now, the images that you're seeing right now in your screen are made up of very, very tiny squares. And every square or lack of a square is a piece of information, of digital information. So the more information you have, the smaller the squares will be, and the more squares you will have. The less information, the bigger the square will be, and the less information you will have. That's why when you see video games, you see the very old video games like Frogger, like Centipede, like Space Invaders, like Pong. Have you seen those games? Anyone knows what I'm talking about? Okay, very ancient game. These are games like when I was a kid. I mean, they were. You looked at them and you're like, "What is that? Oh, that's supposed to be a ball." You see a square. It's not like today. Today, you see one of these video games and they look like a movie, and the characters look like people, and you're wondering if you're seeing an animation or a real person of how incredible it looks. You know the amount of information that is in one of those images. It's astounding, and the resolutions are incredible. Well, back in the stone age of video games, that's not the way it was. The resolution was very poor because images could only hold so much information. But nowadays, the resolutions are vast. Resolutions are incredible. Uh, Back in the early days of digital, we had DV, which is 480 by 720 resolution image. Then from that, we moved on to 720p, which is a better looking image, like those that you find in a DVD. DV is something you would find, a quality you would find in a video cassette, if you know what a video cassette was. When I was your age, we saw movies in video cassettes, and that's the resolution that they had, 480. They didn't look very good. When you compare it to other resolutions, 720 became the DVD, then came 1080. Right now, my TV is a little bit old. It's like probably like 10 years old, and it's a 1080. That's what it's called, high definition. And that would be like Blu-ray resolution. Blu-ray, has better resolution. The image looks better than that of a DVD. And then you have 20K. 20K was never used because we jumped over it quickly to 4K, which is today's standard. 4K is the standard resolution today. And when you see something in 1080 and you see something in 4K, you see the difference. If you go window shopping to Walmart, like I've done, and you see those TV screens, you'll see the image, how incredibly crisp and real it looks. And something in the horizon out there is 8K. Can we see an 8K? Can the human eye see an 8K? Some people say no, that 4K is like the limit of what we can see. But this is a list of the different resolutions that are out there. That this is something you need to know, right? If you're going to be dealing with images. Uh, so there's a little bit more information here that you guys need to read. It talks about the history of HD videos back in the 1980s. It talks a little bit more about resolution. And then it talks about the DSLR camera, which is the camera that we introduced in our last lesson. It gives you a little bit more information here about the DSLR camera. I want you to get familiarized with it because that's the type of camera that we use in this course. So you need to acquaint yourself with it. This is a diagram that you need to memorize because in the next test, I will be asking you this diagram to name the different parts of the camera to me. Notice that light is what a camera records. You see a yellow arrow coming into the camera lens and bouncing inside because what the camera captures is light. And what we see at the end of the day is also light. So that arrow represents light traveling inside the camera. So you're going to look at that. You're going to find this diagram also in my website. Today, you will be working. Okay, there's some information about frame rate. We'll be discussing this in the next lesson because we ran out of time. You're going to do the reshoot activity. Do not send it to me until further notice. And for the portfolio, I want you to draw the diagram that you just saw. And when I tell you to, you will send it to me for the portfolio. It should be done separately, but I'll let you know when to send it to me. Guys, do you have any questions for me before we leave? Because I took a little bit longer than I was supposed to. Okay, well, guys, make sure that you read this. Make sure that you go to my website to find the PowerPoint because I think it has a link to a video that you need to see. And in our next lesson, we're going to be talking about photographic composition. Now, we're going to move to stuff that you need to do, that you're actually going to be doing. Because very soon you're going to have a project where you're going to be sending me a picture, applying the things that you learn. Okay? So, guys, have a great day. I'll be seeing you in the next lesson. Take good care of yourself. Goodbye.